sketching the graphs of logarithmic and exponential functions. There are some steps to take in order to sketch the graphs of such functions. In this video, we are going to talk about those steps. So as you see, there is an example here, an exponential function y is equal to negative 2 times e to the power of negative x plus 4. In general, we know the exponential functions are like a curve, like in this way, or might be like this, or might be like this. But where it is located on the x and y axis is important. Whether they intersect the axis, whether they cut the axis or not, these are the questions that we need to answer in order to draw the graphs. So let's get started with this example and see what we can do. So the first thing that we will be looking at is to determine whether this curve intersects x-axis or y-axis or not, and if they do, at which point. So we need to find the ordered pairs. So in order to determine those points, we need to take this step. So first of all, let's give x 0. Let's say x is equal to 0. Therefore, the value of y will be equal to negative 2 times 0 plus 4, which in this case it will be equal to, so 4 minus 2, because e to the power of 0 will be equal to 1. Okay, any number to the power of 0 is equal to 1. So here it will be 2. That means the curve intersects y-axis. So when x is equal to 0, that means we are talking about the y-axis. So at this point, 0 and 2, the curve intersects this y-axis, okay? And similarly, we need to do the same thing to find out the point on x-axis. So let's say if y is equal to 0, what will happen? Y is equal to 0, therefore minus 4 is equal to minus 2e to the power of negative x, because I moved 4 to the other side of the equation. Therefore, it will be e to the power of negative x will be equal to 2. And then I will take ln from both sides. Ln e to the power of negative x is equal to ln 2, right? So ln 2, or natural logarithm of 2, is equal to 0.69, and ln e to the power of negative x is equal to 0.69, which that means x is equal to negative 0.69. So this is another point. That means y 0 and x negative 0.69, or negative 0.7 almost. All right, okay? So here is the ordered pairs. Okay, so this is another. Now, is it done? It's not done yet. We have another part we need to do to make sure that we can draw the graph, and that is if x approaches positive infinity, what will happen? Then y will approach, what will happen to y? Y will be equal to, so if we just substitute x with infinity, positive infinity, you see there is a negative. So negative times positive infinity will be negative infinity, and negative infinity, e to the power of negative infinity means 0. So 0 times negative 2 will be 0, and then only 4 will be left. Okay? And if x approaches negative infinity, let's see what will happen then. Then negative infinity, we will just substitute it here again. Negative infinity times negative, because there is a negative here, okay? It will be positive infinity. So positive infinity, e to the power of positive infinity will be positive infinity. But we have a coefficient, negative coefficient here. So this negative 2 times positive infinity, it again becomes negative infinity. So therefore, y also approaches negative infinity. So now that will help us to know how to draw the graph, to draw the curve in this case on the coordinate plane. So now we have the points where this curve cuts or intersects the x and y axis. So let's say one is here, as you see, 0 and 2. Another one is, let's say here is negative 0.69. And we have another limitation part here, which is y is equal to 4. That means if x approaches positive infinity, therefore y can only increase until 4. So let me just draw this 4 as the limiting point. Okay. And another part, x goes to negative infinity. If x goes to negative infinity, the curve also moves towards negative infinity, down. It means it goes down towards here, because y will also go to negative infinity. So putting all this information, this pieces of information together, we will see that we need to draw such a curve. So here it will never, the curve will never goes beyond 4. It will maximum, it reaches 4. Y will get to 4. Okay. Okay, so let's solve another example. Do another example. We will take the same steps. Okay, so we say if x is equal to 0, what will happen? Then e to the power of 0 will be equal to 1, and then 1 times 4 will be 4, 4 plus 1, therefore y will be equal to 5. Okay, so this is one point, that this is one intercept point. It means the curve intersects y-axis. And similarly, let's say if y is equal to 0, then what is the value of x? Therefore, 0 will be equal to 4 times e to the power of 2x plus 1, which will be equal to 4 e to the power of 2x is equal to negative 1, and e to the power of 2x will be equal to negative 1 over 4, right? Okay, so now I will take ln from both sides of this equation. It will be ln e to the power of 2x, which will be equal to 2x is equal to ln negative 1 over 4. Okay, so here ln negative number is undefined. So this is undefined. That means when we get to this such case, that means this curve does not intersect x-axis, because we cannot find any value uh, for x, right? We cannot find any value for x because on the x-axis there is is undefined. The curve, the function is undefined. All right, so we have got one point then, which is here 5x5 and y is equal to 0. So this is the point that the curve definitely intersects. Okay, now what else we can do? We need to say, what if x approaches positive infinity? What will happen to y? Then we will just substitute positive infinity here. Positive infinity, e to the power of positive infinity will be infinity times 4 again infinity plus 1. It will also become positive infinity. So therefore, if x goes to infinity, therefore y also goes to infinity from here. Positive infinity. And but how about negative infinity? If x goes to negative infinity, what will happen to y? Then we will just again we will put negative infinity here, so we know that 4 times e to the power of negative infinity plus 1, and any number to the power of negative infinity is equal to 0. So this is 0, therefore y will be equal to only 1. So y approaches 1. Okay, that is the limiting point. That means y can never be less than 1. So here is 1. Okay, so this is 1. Let me draw such line here. Okay, so putting this information all together, we can now draw the curve, and the curve is something like this. Right, because from that side it goes to infinity, both x and y, and here to the left side, as x goes towards larger number in negative side, in negative part, okay, y gets closer to 1, right? But now let's move on to logarithmic equations, and let's see how we can solve this, how we can draw the graphs of this equation. Okay, in this example we will take the exactly the same steps. So say that if x is equal to 0, then what will happen? Because I want to know if the curve reaches y-axis or not, or intersects y-axis or not, right? So therefore I will just put 0 here. 2 times 0 will be 0. 0 plus 4 will be 0. So y will be equal to ln 4, and ln 4 is equal to 1.38. So that means this is one of the points that we got ordered pairs here, or coordinate, 1.38. Okay, and when y is equal to 0, let's see what will happen. If y is equal to 0, then what will happen to x? Then 0 will be equal to ln 2x plus 4, right? And here, how we can solve, how we can go further? Well, instead of 0, I can write ln or natural logarithm of 1, because natural logarithm of 1 is equal to 0. And it will be equal to ln 2x plus 4. Therefore, from here I can conclude that means 2x plus 4 must be equal to 1, right? Yep. And from here we can find the value of x. X will be equal to negative 3 over 2. Okay, so this is another point. Negative 3 over 2 and 0, right? Okay. But there is one thing more left, and that is when x approaches positive or negative infinity, what will happen to y? Okay, I need to test that. So if, let's say, if x approaches positive infinity, what will happen? Positive infinity will be here. So positive infinity times 2 will be it will be positive infinity, and then ln infinity is undefined, and it means infinity, in fact. Yeah, it's a large number. So therefore here again y, we can say y also approaches positive infinity. But can we say x approaches, if x approaches negative infinity? Well, here, because it's a logarithmic equation, we have limitation. We cannot say x approaches negative infinity, because the value here, to make it valid, this equation valid, this expression here should never go below a certain point, and that certain point is it should be always positive. It can never be negative. It should always be positive. Otherwise, ln something negative doesn't make sense, right? So therefore, we cannot say if x approaches negative infinity. Instead, we can say here, so let me erase this part. We can say 2x plus 4 must always be positive to make this equation valid. Okay? So therefore, x has a limitation. X should always be larger than negative 2. Okay? So that is important. X should always be larger than negative 2. All right, so this is what we can do now, analysis. Now let's mark the planes x and y axis by the ordered pairs that we got, and here we have a limited value for x. So let's say here is 0 and 1.38. So 0 and let's say here is 1.38. So this is one point that the curve passes through, and the other one is negative 1.5 here and 0. So here is, let's say this is 1, this is 2. So here will be negative what? Negative 1.5 or 3 over 2, and negative 2, which x always must be larger than this negative 2. And I can draw this graph easily now. From this side, it can continue to positive and positive infinity. And from the other side here, it can intersect negative 3 over 2, and it can continue here. Maximum it can reach negative 2, right? So okay, so this is how we can plot the graph of logarithmic equation or natural logarithm ln. Now let's do another example to see. Here there is another example. So we will take the steps again according to the previous examples. So first of all, I will say x is equal to 0, then what will happen? Then y will be equal to 2 times ln 2, right? And then ln 2 will be equal to 0.69, and then we need to multiply it by 2. It will be equal to 1.38. So therefore it will be equal to 1.38. Okay, and if y is equal to 0, if we say y is equal to 0, therefore what will happen here? Therefore 0 will be equal to 2 times ln, or natural logarithm, 2x plus 2. Now, how to solve this? There is a problem here, and the problem here is we have another term here which is a constant number, 2. So 2 and ln, right? It's not exactly the same as the previous examples where we can just simply set 0, change the 0 to ln1. Here we have 2 also, another value, 2. Well, looking carefully at this equation, we say that 2 times ln 2x plus 2 is equal to 0. So therefore we can say 2 can never be equal to 0. Okay, that means here ln 2x plus 2 must be equal to 0. Okay, because 2 is a number, is a value, constant, can never be 0. And instead of 0, I would like to write ln 1, right? So therefore I can conclude again with the same as is the same as the previous example from here onward. So we can say 2x plus 2 must be equal to 1. We can conclude that. And then therefore x will be equal to negative 1 over 2, right? Okay, so this is another point. Okay, so y 0 and x negative 1.2. So let me just mark the points that I have found here before I forget. So here, let's say here is 1.38 and 0, x is 0, y is here. And another one, y is 0 and x is negative. It means on the x-axis. So here if we say 1, negative 1, it will be like here. Let's say here is negative 1 over 2. Okay? But now here we need to make sure that if x approaches positive infinity, what will happen to y? Therefore, y also approaches positive infinity because it's a huge number, and then ln of positive infinity, of course, it's not defined, but that means a huge number, right? If ln a larger number, the value of y will increase, yeah? So therefore, we say, like, we can say y also approaches positive infinity. But how about the negative side? What about negative side? Negative side, we need to again use the same approach technique. We say that x cannot be any value like negative value, because in order to keep this equation valid, this expression here must be positive. So therefore 2x plus 2 must be positive, it cannot be negative. Okay, and therefore we can conclude that x must be larger than negative 1. So x can never be less than negative 1. Okay, so now I will connect these two points together, and here is the limited point, which is negative 1. Okay, x is equal to negative 1. Okay, so this is the end of this video. Thanks for watching this video. We solved 4 examples, 2 from ln natural logarithm and 2 from exponential functions. Hope you found this video useful and helpful, and if you found that helpful, please like and subscribe. Thanks for watching.